All right, guys, welcome back to our revision. This is part 4 of the series of revision that we are doing for AWS SAA C03, and we are on question number 13. All right. A company performs monthly maintenance on its AWS infrastructure. During these maintenance activities, the company needs to rotate the credentials for its Amazon RDS for MySQL databases across multiple AWS regions. Which solution will meet these requirements with the least operational overhead? Okay, so we want the one that will meet, will meet the requirements with the least operational overhead. If you remember, there was a similar question that we looked at in previous videos. If you look at question number 11, it's basically the same thing. This time it was an EC2 instance running and it uses Amazon Aurora database, and the company wanted to minimize the operational overhead of credential management. And we said that AWS Secrets Manager and AWS Systems Manager Parameter Store are both good, but the one that will give you the most in terms of minimizing operational overhead is the AWS Systems Manager Parameter Store. So we've got a similar situation here where the company wants to rotate the credentials for their database across multiple regions, and they want to do it whilst minimizing operational overhead. So we've got A, store the credentials as secrets in the AWS Secrets Manager and use multi-region secret replication for the required regions. Configure Secrets Manager to rotate the secrets on the schedule. Then B, store the credentials as secrets in AWS Systems Manager by creating a secure string parameter. Then use multi-region secret replication for the required regions. Configure Systems Manager to rotate the secrets on the schedule. C, store the credentials in an Amazon S3 bucket that has server-side encryption enabled. Then use Amazon Event Bridge, that is Amazon CloudWatch events, to invoke an AWS Lambda function to rotate the credentials. Then D, encrypt the credentials as secrets by using AWS Key Management Service, multi-region customer managed keys. Store the secrets in an Amazon DynamoDB global table. Use an AWS Lambda function to retrieve the secrets from the DynamoDB. Then use the RDS API to rotate the secrets. Okay, so you can see that with this particular one, among the options, we don't have the option that we had in 11, where we had the Systems Manager Parameter Store. So what we have here is the Secrets Manager. So if you look at option A and option B, we've got Secret Manager. So we can say that A and B will be competing for the answer, and C and D just probably the distractors. So we can focus on A and B. So A says store the credentials as secrets in AWS Secrets Manager, then use multi-region secret replication for the required regions. Configure Secrets Manager to rotate the secrets on the schedule. So here it looks like the system has been automated for the credentials rotation to be done on a schedule. So once you automate the credential management, then it reduces operational overhead. Then B, store the credentials as secrets in AWS Systems Manager by creating a secure string parameter. So here we've got AWS Systems Manager and AWS Secrets Manager. So A and B, if you look at it, A contains secrets manager. So more or less, we can say that that will probably be the answer. Okay, so yeah, so it's not surprising that the community voted for A as the answer. So 100% of you voted A as the answer. And I believe, yeah, that is it. So AWS Secret Manager, though, does not really offer the least operational overhead. If we had, let's say in the options, if we had AWS Systems Manager Parameter Store, then that will offer the least in terms of operational overhead. But because we didn't have that among the options, then we'll probably go with the AWS Secret Manager. Okay, question number 14. A company runs an e-commerce application on Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto-scaling group across multiple availability zones. Across multiple availability zones. Okay, the auto-scaling group scales based on CPU utilization metrics. The e-commerce application stores the transaction data in a MySQL 8.0 database that is hosted on a large EC2 instance. The database's performance degrades quickly as application load increases. The application handles more read requests than write transactions. The company wants a solution that will automatically scale the database to meet the demand of unpredictable read workloads while maintaining high availability. Which solution will meet these requirements? Which solution will meet these requirements? Okay, so there are some keywords. Multi-availability zone deployment is one of the requirements. And the fact that the application stores their transaction data in a MySQL 8.0 database. So it means it's a relational database. So among these, we have to look at the one that will help in terms of the relational database. And Amazon Aurora looks like the one that is going to help. Okay, so I'm going to go for C. Yeah, the community voted for C. So, you know, if you look at Aurora, it's 5 times, the performance improvement over MySQL on RDS and handles more read requests than write, maintaining high availability. So it's good for multi-availability zone deployment. Okay. And remember, we've got things like MySQL and all of that. Now, let's look at Amazon Redshift. Amazon Redshift. Now, Amazon Redshift is a fully managed petabyte scale data warehouse service in the cloud. Okay. It is designed for high performance analysis and reporting of large data sets. Okay. So when we are talking about petabytes of data, then Amazon Redshift is one of them. So is it used for relational database or not? Okay. Yes, Amazon REST is a relational database management system, RDBMS. It's a fully managed columnar data warehouse service provided by Amazon. So you can see that Redshift, okay, because you've got MySQL in the question, okay, the e-commerce application stores transaction data in a MySQL 8.0 database that is also in a large EC2 instance. Because of that, Redshift and Amazon RDS, they all kind of seems to be competing for the answer, but remember that the deployment is a multi availability zone deployment. And if you look at Redshift, it looks like it's a single AZ deployment. RDS is a single AZ deployment. Okay. And if you look, what is Amazon Elasticache? Amazon Elasticache. Amazon Elasti. Is it all together? Okay. Amazon Elasticache. The name even kind of gives you a clue what is it. So Amazon Elasticache is a managed in-memory caching service provided by Amazon Web Services. So it's a caching service. It is designed to improve the performance and scalability of web applications by allowing you to retrieve data quickly without relying entirely on slower disk-based database. Elasticache supports two popular open source in-memory caching engines. So we've got Memcache, like Memory Cache, and Redis. Okay. Okay. So that is Amazon Elasticache. Okay. So answer is C. Use Amazon Aurora with a multi-AZ deployment. Configure Aurora auto-scaling with Aurora replicas. Right. So if we're talking about petabytes of data, and or if this option gave an indication that it was going to be a multi AZ deployment, even with this RDS, it would give an indication that it was going to be a multi AZ deployment, then the answer would have been quite tricky. But because these two didn't give that indication and C gave the indication, then it becomes an easy choice to make. Okay, so we move on to question 15. A company recently migrated to AWS and wants to implement a solution to protect the traffic that flows in and out of the production VPC. Okay, the company had an inspection server in its on-premises data center. The inspection server performed specific operations such as traffic flow inspection and traffic filtering. The company wants to have the same functionalities in an AWS cloud. So they had an on-prem inspection server, and what it did was it performed specific operations such as traffic flow inspection and traffic filtering. Okay, so we are talking about network stuff here. Okay, so they want the same thing in AWS cloud. What solution will meet these requirements? A, use Amazon Guard Duty for traffic inspection and traffic filtering in the production VPC. B, use traffic mirroring to mirror traffic from the production VPC for traffic inspection and filtering. C, use AWS Network Firewall to create the required rules for traffic inspection and traffic filtering for the production VPC. Then D, use AWS Firewall Manager to create the required rules for traffic inspection and traffic filtering for the production VPC. Okay, so if you look at the options, A is given as the option of Amazon Guard Duty. B is given as the option of using traffic mirroring to mirror traffic from the VPC for traffic inspection and filtering. C is given as the option of AWS Network Firewall. And D is given as the option of AWS Firewall Manager. Okay, so definitely it's going to be a firewall solution. So I think it's going to be either C or D. But as to which of them, that is where some bit of analysis is, required to be able to know which of them. So if let's say we go for C, you can see that AWS Network Firewall can be used to create rules for traffic inspection and traffic filtering for the production VPC. What is AWS Network Firewall? It's a managed firewall service that provides filtering for both inbound and outbound network traffic. It allows you to create rules for traffic inspection and filtering, which can help protect your production VPC. Okay? Now, if you look at D, AWS Firewall Manager, okay, is a security management service that helps you to centrally configure and manage firewalls across your account. It's not a service that performs traffic inspection or filtering. Okay, so that is why option C is the correct answer. Yeah, and 91% of the community voted for option C. Now, Amazon Guard Duty. What is it? Amazon Guard Duty is a threat detection service. It's not a traffic inspection or filtering service. It's a threat detection service. It's used for threat detection. So if the requirement was for threat detection, then we would have probably considered Amazon Guard Duty. Okay. Now, traffic mirroring. What is it? So it's a feature that allows you to replicate and send a copy of network traffic from a VPC to another VPC or on an on-premises location. It is not a service that performs traffic inspection or filtering. Okay, so that makes the answer, very obvious that it is C. Great. Question number 16. A company hosts a data lake on AWS. The data consists of data in Amazon S3 and Amazon RDS for PostgreSQL. The company needs a reporting solution that provides data visualization and includes all the data resources within the data lake. Only the company's management team should have full access to all the visualizations. The rest of the company should have only limited access. Which solution will meet these requirements? Which solution will meet these requirements? Have a think about it and let's see what the answer is. Now, this is a tricky question because if you look at the question again, the company needs a reporting solution that provides data visualization and includes all the data sources within the lake. So immediately you see data visualization, and only the company management team should have access to all the visualizations. Then you might think, then it should be Amazon QuickSight, because Amazon QuickSight is a fast cloud-powered business intelligence service provided by Amazon Web Services. It allows you to analyze and visualize your data to make informed business decisions. Okay, so it makes sense to think that it's either A or B. And you might not even look at C and D, but C and D also talks about, some services that really meet the requirements that is specified in the question. Okay, so it's important to look at the holistic thing instead of just focusing on the visualization. So it's a tough one, but I'll probably go for B or D. I'll probably go for B or D. I'm not sure. So, but I think the answer is going to be B or D. Okay. So the answer is D. But 80% of the community voted B as the answer. I'm not surprised because of the fact that the company needs a reporting solution that provides data visualization, and Amazon QuickSight happens to do that. Okay, so let's look at this AWS Glue table and crawler. AWS Glue table. What is it all about? So AWS Glue table. So in AWS Glue table, a table is a meta data definition that represents structured data in a data store. Tables are used to define the schema of your data, and AWS Glue uses these table definitions to generate ETL, extract, transform, load scripts for data processing. So here are the key aspects of an AWS Glue table: the schema definition, data versioning, data log, data source and target, blah, blah, blah. Okay, so if you look at the question I asked ChatGTP, and it says the answer is actually D. And here is the explanation. It says AWS Glue and crawler. By using AWS Glue, you can create a centralized metadata, as we've already read about, repository for your data lake, which includes data in Amazon S3 and Amazon RDS for Postgres. So one of the requirements is to have a centralized metadata repository for the data lake. So it cannot just be, it's not just you creating visualizations from your data lake, but you need a centralized repository for your data lake. And that is where AWS Glue and crawler comes in. AWS Glue crawlers can automatically discover the schema of your data and create tables in the AWS Glue data catalog. Okay. Now, in D, the second part of D says use Amazon Athena federated query to access data within a Amazon RDS for Postgres SQL. So Amazon Athena federated query. Amazon Athena federated query allows you to run SQL queries across data stored in Amazon S3 and Amazon RDS for Postgres SQL. It provides a unified view of your data sources, enabling you to generate reports without the need to move data around. So it's a query services. Amazon Athena is a query services, and it helps you to run SQL queries. So it's used for running SQL queries from your Amazon RDS for Postgres SQL. Okay, and the other aspect is report generation. So by using Amazon Athena, you can generate reports based on SQL queries that join data from both Amazon S3 and Amazon RDS for Postgres SQL. This allows for comprehensive analysis across your data sources. Then the publication of the reports S3. After generating reports using Amazon Athena, you can store the results in Amazon S3. This provides a scalable and durable storage solution for your reports. And 5 is access control. By using S3 bucket policies, you can restrict access to the reports in Amazon S3. This ensures that only the appropriate users or roles have access to the visualization stored in S3. Okay, because that's one of the requirements. If we go back, it says that only the company's management team should have access to all the visualizations. Okay. So that is why we need to use S3 bucket policies to limit access to the reports. Okay. If you look at this, it doesn't talk about generating the report. Let's see. Yeah. So that is it. That makes D the best answer. Right. Question number 17. A company is implementing a new business application. The application runs on two Amazon EC2 instances and uses an Amazon S3 bucket for document storage. A solutions architect needs to ensure that the EC2 instances can access the S3 bucket. What should the solution architect do to meet this requirement? Okay, so if you look at the options, A, create an IAM role that grants access to the S3 bucket. Attach the role to EC2 instances. B, create an IAM policy that grants access to the S3 bucket. Attach the policy to the EC2 instances. C, create an IAM group that grants access to the S3 bucket. Attach the group to the EC2 instances. And D, create an IAM user that grants access to the S3 bucket and attach the user account to the EC2 instances. So we've got IAM role, IAM policy, IAM group, and IAM user. It's important we understand what these are, and that can help us to know the answer. So have a think about it. But as you're thinking about it, let us review what IAM role, IAM policy, IAM group, and IAM user is. Okay, so in AWS Identity and Access Management, so IAM is Identity and Access Management. Identity and Access Management. So in AWS Identity and Access Management, IAM, roles, policies, users, and groups are fundamental components used to manage access control and permissions for AWS resources. Now, here's what each of them is. So Identity Access Management user represents a person or service that interacts with AWS resources. So users have unique credentials, that is username and password or access keys, can be assigned permissions to access specific AWS resources and perform specific actions. So a person or service that interacts with AWS resources. We come back to the question. There is no mention of a person. It says the application runs on two Amazon EC2 instances and uses an Amazon S3 bucket for document storage. So there's no mention of a person, just services, EC2 instances and S3 bucket. Okay, so maybe we can, we can ignore IAM user because there's no specific mention of a person. Okay. All right. Identity and Access Management Group. An Identity and Access Management Group is a collection of IAM users. So if you've got IAM users, a collection of them. So groups make it easier to manage permissions for multiple users. Instead of attaching policies directly to users, you can attach policies to groups, and all users within that group inherit the group's permissions. So if you look at the question again, there's no mention of users, so we can't use Identity and Access Management Group. Then we have Identity and Access Management Role. Now this is similar to a user, but it's not associated with a specific person or group. Instead, it is assumed by entities such as AWS services, EC2 instances, or users from other AWS accounts. Roles define a set of permissions for making AWS service requests. Roles are used to delegate access across AWS accounts and services securely. Come back to the question. We've got services, Amazon EC2 instances, and S3 bucket. And we've learned that roles refers to services. So it means that A can be a possible answer. Let's look at what Identity and Access Management Policy means. Now, Identity and Access Management Policy is a document that defines permissions. It specifies the actions that are allowed or denied on AWS resources. Okay, so that is it. Policies can be attached to users, groups, or roles, defining what actions those entities are allowed to perform. Policies are written in JSON format and define the permission user statement. So policies defines the permissions. And this is an example of an IAM policy. You've got your version, the statement, effect, action, resource, then effect, action. Yeah, so this is an example of a policy. Okay. The answer is obvious, is A. Create an identity and access management role that grants access to the S3 bucket, attach the role to the EC2 instances. Let's see what the answer says. Yep, 99% of people in the community voted for that, and the answer is A. Perfect.